Good morning to everybody. I am Paolo Croce and I am one of the authors of the paper entitled The Interdisciplinary Role of Archaeoacoustics and Its Applications. The other authors with me are Francesco Leccese and Giacomo Salvadori from the University of Pisa and Umberto Berardi from the Ryerson University, which recently became the Toronto Metropolitan University. In this work, we have analyzed the contributions in the field of archaeoacoustics and their progress in order to better define this emerging discipline, in order to understand its fields of application and trace a common path for future research. During this presentation, we will look at the origins of archaeoacoustics. We will look at when it was born and who were the early pioneers. What are the objectives of archaeoacoustics and why this kind of research is necessary? We will then move on to the obstacles and on what makes the analysis of an archaeoacoustic site difficult. We will also highlight what elements should be paid more attention to. Finally, a methodology will be proposed by the authors that aims to make consistent the contributions of the different figures that interface with archaeoacoustics, even considering that the figure of the archaeoacoustician does not yet exist, and that archaeoacoustics, being an interdisciplinary subject in itself, requires the collaboration of several figures. So let's start from the origins. Archaeoacoustics was born from what is defined as music archaeology, a field of research that investigates the music of past eras through archaeological evidence. The natural step, thanks to the increase in technology and knowledge, was to extend the concept of instruments to archaeological sites, recognizing their characteristic sound behavior. Although there are also earlier contributions, the first pioneers are considered to be Watson and Keating, an archaeologist and an acoustician who conducted a series of acoustic analyses of megalithic monuments in prehistoric Britain. A famous case study is Stonehenge, which features two stone circles that filter sound outward and create distinctive echoes that probably enhanced the building's ritual use. In 2006, the first book on archaeoacoustics edited by Scare and Lawson was published. The book collects the contributions of a conference held at the MacDonald Institute in Cambridge, in an attempt to give a clear definition and direction to the nascent discipline of archaeoacoustics. Subsequently, other conferences were organized by the OTS Foundation in 2014 in Malta, in 2015 in Turkey, and in 2017 in Portugal. Within archaeoacoustic research, we can find research areas such as the Mesoamerican architecture, and an example is the Mayan Toltec stepped pyramid temple called the Castillo at Chichen Itza in Yucatan, Mexico. The peculiarity is that a percussive sound made in a certain area, to the north of the Castillo, results in a curious chirped echo that sounds like the call of the Quetzal. That was a bird of colorful plumage sacred to the Maya. Then we can find places from Greek mythology. An example is the Cumaean Sibyl cave at the northwest of the Gulf of Naples, in Italy. The acoustic characteristics are compatible with the myth according to which a visitor walking along the corridor to reach the Sibyl was guided by an unintelligible voice that became clearer once he got closer. Finally, we can find theaters, with particular reference to the ancient open-air theaters. Here is reported as an example the theater of Pompeii, in Italy, whose current acoustics is compromised by the partial disappearance of the chenefronts. But what are the objectives of archaeoacoustics? The main objective is to create a biunivocal correlation between the acoustics of a place and its function or use. This is necessary for multiple reasons. First of all, we live in a culture in which the primary organ is sight, and it is strange for us to think that in other times or cultures it might not be so. Especially in societies born in hostile environments or whose primary activity was hunting, the activity of listening was of vital importance. The sound could assume metamorphic or mystical characteristics, especially when the sound source was not well identifiable, and the sound seemed to come from another dimension. Moreover, it should not be forgotten that the sound-silence relationship has strongly changed. An example is the sound perception inside cathedrals. While cathedrals were built for people immersed in silence, who found echoes and reverberations that suggested the presence of the divine, they are now experienced by people immersed in noise, who find in these places atmospheres of peace and silence. A first classification of the sites, in fact, can be made by distinguishing the acoustic effects present within them. Firstly, acoustics may be an integral part of the design, as it probably was for Stonehenge, since the stone used was not taken from the nearby area, but was transported from an area of spiritual significance. This suggests that the builders were aware of the acoustic properties of the specific stone. Secondly, acoustics can be an accidental byproduct of the design, but one that was recognized after construction and used, as in the Whispering Gallery at St. Paul's Cathedral in London, that allows whispered communication from any part to the other. Finally, acoustics can be an accidental byproduct of the design, but was never used intentionally. An example is the main chambers of the Great Pyramid in Egypt. But what is that makes archaeoacoustic research difficult? The main obstacles are that there is such a heterogeneity of situations, cultures, and places that it is not easy to identify a common methodology, that there is no fixed range of frequencies, but often special attention must be paid to specific frequencies, or site behavior must be analyzed for different ranges. Also, from a practical point of view, how do I arrange source and receivers in environments where ritual activity did not distinguish between those who played or sang and those who listened? Another problem is represented by the fact that in archaeoacoustic sites, often the geometry is complex or cramped. How can I take reliable measurements while maintaining distances between source and receivers, or between receivers and walls? And once the measurements have been made, what are the parameters I have to take into account and what are the reference values? A curious aspect is the fact that often some acoustic phenomena present in these sites, such as echoes, flutter echoes, filters, are more difficult to analyze because they have been studied less in modern architectural acoustics. The reason is that they are effects considered negative, and therefore to be avoided. In archaeoacoustics, on the other hand, they are often the reason why a particular place was built or chosen. A unequivocal answer to these difficulties cannot be given, because each site has its own conformation and its own characteristics. But what can be done is to look for a common methodology that allows to be able to organize and make consistent archaeoacoustic studies. In this regard, a flowchart has been created, which, starting from an archaeoacoustic site, describes the macroscopic aspects to be taken into account. In particular, it has been taken from the literature a sound distinction in three macro areas that allows to identify the different sound behaviors of the site. These are the live sound, based on the still living, the harmonic sound, based on the inaudible relation of acoustic principles and the geometry and proportions of architecture, and the impulsive response, based on the in situ measurements or on virtual model examination in specialized software. Live sound can be divided into a soundscape component, which has probably changed over time, and a performance component, based on the activities that took place within the site. Depending on the state of preservation of the site, activities may be reproduced or simulated. Live sound can then be assessed from a subjective perspective through the use of binaural recordings, the use of interviews and questionnaires, and the observation of how subjects move within the site, how they experience its acoustics, and how the site leads them to move within it. Harmonic sound can be divided into the study of possible acoustical devices, as could be the acoustic vessels described by Vitruvius and present inside theaters or churches, the study of materials, as may occur in the analysis of the evolution of Greek theaters, which passed from wooden structures to stone structures, and the study of shapes, whose change modifies the acoustic characteristics of a place, as happened in the passage from the Greek theater, more open, to the Roman theater, higher and more closed. Finally, the impulse response of the place, which is strongly related to the real acoustic measurements. In particular, the major distinction is based on the state of preservation of the site, which describes the reliability of the acoustic measurements that are made within it. If the site is totally or partially compromised, or if its context has been completely altered, the best choice is to simulate the acoustics in a virtual environment. A particular consideration should also be made, as already mentioned, on the arrangement of source and receivers if there is no clear distinction between the two parts. The results thus obtained can then be used to calculate and analyze the acoustic parameters of interest and to identify any acoustic phenomena present. These phenomena can then be evaluated on the basis of their effect on the human brain. In conclusion, archaeoacoustics is a relatively new field of research, born as a multidisciplinary field. It is therefore a field with enormous possibilities of study, but often requires the participation of scholars from very different fields of research. At the moment, in fact, there is no figure, the archaeoacoustician, who can encompass all the knowledge necessary for the organization of an archaeoacoustic research. What has been proposed is therefore a research method that allows in a simpler way the organization of the contributions of the various scholars and their choice. Anyway, for those interested in deepening the topic, a basic bibliography with the main references is proposed here. In the hope that you may have found this presentation interesting, I thank you for your attention.